In this tutorial, we're going to talk about section 9.1, translations. The first thing that we want to do is define a couple words, so let's get that going. So the first word that we have is transformation, and a transformation basically is a change in a geometric figure's position, shape, or size. And all transformations have to have some kind of a starting point, which we happen to call a pre-image. So for example, we have a smiley face. And this is what my image looks like before I do anything to it. That's why it's called a pre-image. After I do a transformation, that is just called a basic image. So I could do several different things here, but let's say I have a larger face and it turned on its side. So that would be my image after I do a transformation on it. And the last thing that we need to talk about with pre-image and images is there's something called an isometry. And if you happen to do a transformation on a pre-image and after you do that transformation it comes out to be congruent, then it's called an isometry. It can still be rotated and reflected in a different place, that's fine. But as long as I have a congruent image, in other words, all the angles and all the sides are congruent, then it's called an isometry. So there's some notation that we want to make sure that we go over as well. If you're not told which figure is the pre-image and which one is the image, there's a very easy way of seeing just what's going on. In your pre-image, you will see your letters for your vertices just normal, so J, K, Q, nothing fancy. In your image, you will see the letters with a little dash above it like that. And the way that you say that is J prime. And then we have Q prime and K prime. So this particular transformation looks like it's a reflection, as if it was looking through a mirror. So this blue line could represent the mirror. Okay, and just to make sure, this is our, oops, I am writing all over the place. This is our pre-image over here, and this is my image over here. And another way to show this is I could use notations such as this. I could say K maps onto, that's kind of like what that symbol there means, maps onto K prime. Or I could say J maps onto J prime. I could even tell you the entire figure. So triangle JKQ maps onto triangle J prime, Q prime, K prime. Oops, I'm so sorry, I did that in the wrong order. See, I'm going nuts. That would be K prime and Q prime. There we go. Same order now. So that's how you can use all your notation to help you determine the pre-image and the image. So what particularly is a translation? And a translation is an isometry, in other words, the pre-image is congruent to the image, that maps all points of a figure the same distance in the same direction. This can also be called a slide. Okay, so nothing changes in the shape or the size of the figure, it's like it's being slid across a table, it's just moving its position. So let's take a look at an example. So let's take a look at this. Let's first of all read the instructions, don't get overwhelmed by the picture, but this is our instructions. It's saying you're doing a translation on X and Y, and of course it's X and Y because we are dealing with our normal coordinate system, and it's mapping onto, that's what that arrow means, X plus 4, Y minus 2. So what does that mean? So let's try to isolate this. We're not even looking at the picture yet, but this X represents the pre-image, okay, the pre-image X coordinate. So let's take one of our points over here, either A or D. Let's talk about A first. Okay, and the x-coordinate here is -3. Okay, so in order to find my image, in other words, after my transformation here, I would follow the rule for the x's right here. So if I follow that rule, then that means I'm going to do -3 plus 4 to get the x coordinate of a prime, and that is equal to 1. So I know that a prime will have to have the x coordinate of 1 comma something. Okay, so then how would I find the y coordinate? Well, here's my y right here, and for a originally y was equal to, let's see, 3. So this is our point right here. And it's saying take your y value and subtract 2 from it. So I would do 3 minus 2, which is equal to 1 as well. So that gives me the y coordinate for a prime. So I can go over here in a prime and I can go ahead and label where this point is, 1 comma 1. And that's without even having the axes or the tick marks on here. I don't have to have them because I have my instructions right up here. Okay, so then let's try to do this with D. Let's go ahead and find our coordinates for him. So for D, it looks like my x value here is -3. So to find the x value for D prime, I'm going to do -3 plus 4, and that's going to be equal to 1 again. And then for the y is initially equal to +1. Okay. And so that's for D. So D prime is going to be 1 minus 2, which is equal to -1. So I can go over here where D prime is on my map, on my graph, and down where it says D prime, I'm going to go ahead and write in -3, comma, -1. So that's how we can do a translation with this kind of information. Okay, so in this example, we're going to do just what we did, but backwards. So the instructions for this problem are write a rule to describe the translation from figure PQRS onto P prime, Q prime, R prime, S prime. And it helps us by giving us these 2 points. So we're going to use P, -1, -2, and that is from my pre-image, because there's no prime. And then P prime is its image. So I have to figure out what's going on in these 2 figures over here of their x's and their y's. So let's first of all work with our x's. We'll do the horizontal change. Oops. Okay. So you want to think to yourself, how did I get from my pre-image to my image? And you kind of want to think of it in the opposite way. So start with your image x value. And in this case, I have -5, this guy right here. So I'm going to start with -5. And just like as if you were doing the slope, you subtract these values to find the difference. So -5 minus -1. So how far away are these points? So that would give me -5 plus 1, which is equal to -4. So when I write my rule, that is going to come into play. Now let's try to figure out what our vertical change is. And I'll do this one in orange. So start with your image first. So I have -1, and I'm going to subtract -2. Let's see what happens here. So I have -1 plus 2 to give me +1. So what is the rule then? I'm going to have to come back up here. I'll do this in purple. What is the rule? So here's how we're going to write it. I'm going to say x, comma, y. That's my pre-image, and it maps onto these instructions. So we're going to do the x part first. So I have to start with x. And if you look back down here when we figured out our horizontal shift, I got -4. And that's exactly what I'm going to write right next to this. So x minus 4. That's my rule. For the y part, I'm going to start with y, and then I'm going to write +1 since that is positive. So that's all you need to do. All right. And our last topic to talk about is a composition of transformations. And all a composition is a combination of two or more transformations. So let's take a look at a quick example. Okay, so here we have two different rules. We have the first one being right here and the second one being here. And we're going to start with point P in this location. So what I can do is I can go ahead and do my first translation. So I'm going to get my parentheses set up, and I'm going to stick with red for my x's and blue for my y's. So the first rule says take your x's and add 2 to it. So I go over here and I look at my x's, which is 1. So I would do 1 plus 2, which would give me 3. And then I'm going to do my y's. So here's my y, and here's my rule for it. So 0 plus 1 is 1. So after I do my first translation, I now am going to do my second one. I'm going to open up a new set of parentheses, and this time I'm not going to use my original coordinates. I'm going to use my new pre-image, which was previously the image. So I'm going to use this coordinate here to move on. So this is my new x value, and this is my new x rule. So 3 minus 5 is -2. And then 1 is my y, so y plus 3. 1 plus 3 would give me 4. So if you have a composition of transformations, your final answer is the answer that you're looking for. And that concludes this tutorial.